This week's topic is speech and hearing. This is the outline. I will start with speech, talk a little bit about the functions and phonetics of speech production, and then I will talk about hearing. That means the ear and psychoacoustics. So let's start with speech. Actually, speech is just one part of language use. It's not the written one, but the spoken one. Here's a citation from Seppok, who says, speech is a subsystem of language, namely communication using language in the acoustic channel. There's an alternative way, which is dedicated to the articulation of phonetics and speech, and this is by Stetson, who says, speech is rather a set of movements made audible than a set of sounds produced by movements. So let's come to phonetics. What are actually phonetics? If we have a look at this kind of linguistic hierarchy, the first one, the most abstract one, is pragmatics. Pragmatics in linguistics deals with the meaning and intention of the user or a person uttering something. There's also semantics. This is about the meaning of single sentences or the factual information. So this is about the relationship between a sign, the letters, for example, in written language, or sounds and words in spoken language as well, and its dedicated or assigned meaning. We also have syntax, that is the laws and the structures of different words and parts of a sentence. There's morphology, what makes actually the different words in which subgroups or entities are used for building up words. There's phonology, the structure of the sounds, the spoken sounds, and finally there's phonetics, and this is how spoken sounds are articulated, how they are manifested in the acoustics, and how they are perceived. So in phonetics, there are several different important definitions. One is a phoneme. So what is a phoneme? It is actually the smallest segmental unit of a sound employed to form a meaningful contrast between utterances of words. So a typical example would be the functional analysis between the two words pit and bit, or even kit and hit. So here we have different words and really small acoustic and phonological differences. These are the single sounds, and these make different phonemes. So P and T in English, pit and hit, P and H would be different phonemes. So a phoneme is actually a functional class which is restricted to a given language. In contrast to this, what is a phone? A phone is the smallest segment or unit in phonetics and speech. So a phone is dedicated to or assigned to the phonetics level, not to the phonological level. You could argue that each phoneme has a phone that is used for producing them, this abstract linguistic unit. But we also have allophones. So what are allophones? Allophones are different phonemes or phone classes, articulatory class, acoustic classes, which differ on a phonetic definition and classification from phoneme classes. So we have two ways to find allophones. The more simple one are free variants. Consider, for example, in English or German, the R sounds. So typically there's no functional or meaningful distinction between using the back R or the front R, but they are phonetically different. That means the acoustics, the perception and the articulation is different. But from a functional point of view, in phonology, they are not different. Therefore, they belong to the same phoneme class. There's another version of allophones, And these are allophones which are distributed in such a way that you cannot make a functional distinction between them. A typical example would be in German the ich and the ch sound. So ich and ach sound. This is also holds for Greek. So these are phonetically similar, but they are not identical. You would say they are different phoneme classes. I'm sorry, they are different phone classes. But because they do not occur in the same position, we will never find a German word which is distinguished by the ch and the ch sound. And therefore, they functionally belong to the same phoneme class. What is a morpheme? In contrast to the phoneme, which is the smallest segment that is giving a difference in meaning, a phoneme is the smallest unit that is actually having some meaning. So word stems are morphemes, but also all these declinations or other grammatical markers which show us like plural or gender of a word, all these are morphemes. So let's consider the example of painter. Paint is a thing, and painter is a person who uses paint. So the ER is this small syllable is actually a morpheme, and paint is a morpheme as well. And as I used the word syllable, syllable is actually not dedicated to the different linguistic levels. This is a term from phonetics, and it just means that it is a unit of articulation. Typically, a syllable has a vowel or something like a vowel in the center and may have different consonants or other sounds. Often, a morpheme is a syllable, but not necessarily so. So morphemes can actually have also two syllables, but most have one. And using the same example again, painter, you can see the clear difference between the syllable and the morpheme, because the border of the syllable would divide painter in pain and ter. But the morpheme border is clearly after paint. So ER would be the morpheme. So the whole speech production process is nicely covered by another video by my colleague Sebastian Moller. This is there's a link on the ICES platform. But there are a few things that I want to stress out nevertheless. The important thing in speech production is that we have a so-called source filter theory. That means there's a model that assumes that speech production in humans, at least voiced speech production, consists of two elements. And this is an excitation that is happening here at the vocal cords, vocal folds, where an excitation signal is produced. And this is formed by a kind of filter function in the rest and the upper parts of the articulatory organs, like the throat, the mouth, and the nasal cavity. I have a display here, a graphic showing on the upper side the voice source, the excitation function. And this is when the vocal folds vibrate passively, rapidly coming together. And this is not a sinus. This is really more like an abrupt closure of the vocal folds that you can see. The result of this is actually that we have a kind of line spectrum. This is a second picture on the bottom of these slides. So we have the fundamental frequency of the vocal folds coming together and closing and opening again. But we also have multiples of this frequency in the spectral domain. And this is now formed by the specific characteristics of the vocal tract, it is called, so the upper regions that we can actually manipulate by moving our tongue, our jaw, our lips, and activating the nasal cavity as well by lowering the velum. There's a nice YouTube video showing this source filter theory in action. You will see for the male A sound, A vowel, an excitation function by loudspeaker. And then the person who produces the video will show a kind of manually produced plastic thing that actually represents the vocal tract, so the throat, mouth of an articulated R. And you can then listen to the source, the excitation signal, and the R sound, the R vowel, which comes from the lips. So the result of this filtering of the vocal tract signal of the excitation function is then the final spectrum. This is a recording that I made, and you can still see the line structure a little bit, but especially you can see some resonance frequencies, the so-called formants, which are quite unique for a particular vowel. And this is what is the most important perceptual cue for identifying different vowels. Here's a table of English sounds. They are the consonants and the vowels. So the vowels don't have any strong constriction in the mouth, but they have a certain pattern by the jaw, the opening of the lips and the lowering of the jaw, and the position of the tongue. And this is a two-dimensional distribution or two-dimensional display of the different sounds, the different vowels that we have. And this is according to the opening of, or the position of the tongue, whether these are high vowels with a more closed mouth and a high tongue position like E and U, and low vowels which are more open and a rather low position of the tongue like the R. And then we have front and back vowels where the tongue is has a certain movement towards the palate in the front or in the back. And the front would be like E or Ä, and the back would be U or O. This corresponds rather loosely, but it corresponds to the formant frequencies of the first and the second so-called formant, which are the first and the second resonance frequency. You will have an assignment where you have to measure your own formants. The consonants in this table are separated according to the manner and the place of articulation. The place of articulation just tells us where is something happening in the mouth, like in the front, at the lips, or more in the back, at the velum. And then we have different manner of articulation. So for consonants, there are plosives, where there's a real closure somewhere, so no air is coming out of the nostrils or the mouth. And this closure is then abruptly opened by a so-called burst. So plosives are P or T or K. And then there are fricatives, where there's no true closure, but there's a constriction, and this constriction is causing a kind of turbulent noise, like S or F or Sh. And then we have other consonants which are even less strong constrictions, like laterals or approximants. The thing is that all these consonants have two kinds of sounds, either being voiced or unvoiced. So whether there is activity vibration in the excitation function, or whether there is excitation or not. So for example, there is B and P. The first one was voiced. The second one, there was no activity here in the at the vocal folds. Same we have with sh and zh. The second one was voiced. The only one which is rather difficult to articulate, unvoiced, are nasals. So nasals are where we have a clothing in the mouth, but the air is coming through the nose, like These are most often or most typically voiced, because it's rather difficult to produce any kind of acoustic intensity without this voicing when the mouth is closed. Now I will show you some examples of some of these consonants by this online synthesizer. What you can see here is actually a cut through the head. And here are the lips. And here is the voice source, the larynx, which has the vocal cords, vocal folds, and produces the excitation function or the excitation signal. And this small synthesizer now allows us to move a little bit the tongue here, and this is actually the restriction that we can manage to build here. And of course we have the nasal cavity as well that we can also use. So I will produce now a small sound source. And in general, the vowels are dependent on the vocal tract shape. That means where the tongue is located. But let's come to the consonants. So the consonants, they are plosives. Where there's a complete constriction, the complete closure of the mouth. And plosives have, as all the other consonants, a certain place of articulation. I'm trying to do a ga. Of course, with the sound source voiced, you always have voiced consonants right now. There's also the L, which should be not a plosive and not a fricative, but there is much more air that can pass through this constriction. And then we have as well the nasals. Let's go back to the R for some other nasals. The last slide on speech production is about prosody. So I've now talked a lot about sounds, and these are rather short term, right? So these have like durations of, let's say, 50 to 200 milliseconds. But of course, when we speak, we produce a lot of other signals and information. We have, for example, the pitch contour. So the frequency, the fundamental frequency of our vocal folds, and this changes in a kind of intonation or melody. This is typically assumed to be prosody. So all so-called super-segmentals are prosody. So slowly varying and aspects of our speech production, and also aspects which are not restricted to a single segment. So for example, how the intensity is prosody. So how loud do we speak? How loud are the sounds? and especially how is the sound pattern over time. The same with the fundamental frequency, the intonation. And then we have also duration. That means how long are pauses, how long are the segments or the sounds that we produce. Do we speak rather quickly or rather slowly? And this prosody is also relevant for linguistics, of course. For example, in German and other languages, Germanic languages, we have the distinction of a sentence being being a statement. Yesterday it was cold, or being a question. Yesterday it was cold, and this is purely intonation. This means the pattern of the fundamental frequency in the pitch. So this is prosody. But also prosody plays an important role for non-verbal information. So information which are not part of our spoken language, but part of other signals like our emotions or irony, or even expressing who we are and where do we come from. I will talk about non-verbal information in a different week.